Hey everyone, and welcome to this deep dive where we're going super deep on a research paper that's all about giving computers a whole new way to see,
Yeah.
not just through code, but through language,
Mm.
like rich, nuanced
Yeah,
language,
right.
just as we use it. So imagine being able to explain what you want an AI to do with an image,
Wow.
and it actually
Yeah.
understands you. That's the potential of explanatory instructions, which is the focus of today's deep dive. And
Exactly.
to make this even cooler, the researchers behind this idea, they actually went and created a massive data set called DECVT, which stands for Dataset of Explanatory Computer Vision Tasks.
Yeah.
And it has something like 12 million pairings of images and instructions.
That's right. 12 million.
It's wild.
It's really remarkable because it represents a shift from telling AI what to do to explaining why.
Oh, that's interesting.
Current computer vision systems, they're great at things like identifying objects,
Right.
but they don't really understand the objective behind those tasks. And this research aims to change that.
Okay, so it's like the difference between like giving someone a recipe versus teaching them like the principles of cooking.
Yeah.
With the recipe, you're just following steps.
Right.
But understanding like the why lets you adapt, get creative, and invent like whole new dishes.
That's a great analogy because explanatory instructions, they provide that deeper level of understanding for AI.
Huh.
So for example, instead of simply saying like, detect the cat,
Yeah.
an instruction might be adjust the lighting to make the cat appear as a silhouette against the sunset, emphasizing the texture of its fur.
Oh, wow. So much more descriptive and nuanced.
Much more so.
Okay, so how does this massive data set, DECVT,
Mm.
how does that fit into this whole thing?
DCVT is essential because it provides the AI with a huge amount of examples to learn from.
Got it.
Examples that showcase how detailed language can be used to describe a really wide variety of image transformations.
Wow.
The goal is for the AI to understand the intent behind any visual task,
Interesting.
not just the specific words in the instructions.
So it's not just about memorizing commands, but about learning to interpret and apply the instructions flexibly.
Exactly. And to test this, the researchers, they trained a vision language model using DECVT.
Okay.
And this model is unique because it's designed to generate images from instructions. Not just match images to instructions. It's about creation, not just recognition.
That is fascinating. I was reading about this concept of zero-shot generalization.
Yes.
Can you explain what that is and why it's such a big deal?
Of course, zero-shot generalization is the ability of a model to perform tasks that it wasn't explicitly trained for.
Oh, wow.
It's like learning a concept in one context
Right.
and then applying it to a totally different situation.
I see.
In this research, there are two types of zero-shot learning that were tested.
Okay, let's break those down. What was the first type?
The first is called instruction-level zero-shot learning.
Okay.
It means that the model can understand and execute instructions that it has never seen before,
Wow.
going beyond simply matching keywords.
So it's actually grasping the meaning behind the words
Exactly.
and applying that understanding to new situations.
That's right.
That's impressive. What about the second type?
The second type is called task-level zero-shot learning, and this is even more remarkable.
Okay.
This means that the model can perform entirely new types of tasks that it wasn't specifically trained to do.
Could you give me an example of what that looks like in practice?
Certainly. One example from the research involved turning a simple edge map, basically an outline of shapes,
Yep.
into a full-color image using only explanatory instructions.
Oh, wow. That's so cool. So it's like the model is filling in the blanks using its understanding of the instructions and its knowledge of the world to create something totally new.
Precisely. And the researchers found that the model was really quite successful at this, demonstrating a level of visual understanding that goes beyond simple pattern recognition.
So what's the secret sauce here? How is the model able to achieve this level of understanding?
Well, that's where DECVT plays a crucial role. By training on such a massive and diverse data set, the model learns to connect specific words and phrases to a huge range of visual features and transformations. It's like learning a new language.
Right.
But instead of words and grammar, it's learning about shapes, colors, textures, and how they can be manipulated.
So fascinating.
Yeah.
This is all so exciting.
It is.
But I want to make sure we understand the limitations of this approach as well.
Sure.
I know the paper mentioned that task-level zero-shot learning was mainly observed in certain types of tasks.
That's right. Task-level zero-shot learning, while promising,
Yeah.
is still primarily observed in tasks like generating images from simple inputs,
Okay.
and those that involve less abstract transformations.
So while the model can generate a realistic image from a simple sketch
Yes,
or enhance an existing photo based on detailed instructions,
right.
it might struggle with more complex creative tasks
Yeah.
that require a deeper understanding of abstract concepts like style, mood, or composition. So there are still some hurdles to overcome before we can truly unlock the full potential of explanatory instructions.
There are, but even with these limitations, the possibilities are incredibly exciting.
They are. Imagine being able to describe exactly what you want to see in an image and then having AI generate it for you down to the smallest detail.
It's mind-blowing.
I know. That's a world I want to live in. But I'm also curious about what's happening under the hood. How
Yeah.
does the model actually process these explanatory instructions
Yeah.
and translate them into visual transformations?
That's a great question, and that's exactly what we'll be diving into next.
Okay.
We're going to explore the inner workings of the model
Can't wait.
and how it connects language to visual understanding.
This is getting more and more fascinating by the minute.
I know, right?
Can't wait to unpack that in our next segment.
Mm.
Stay tuned, listeners.
Definitely. So let's dive into how the model connects language to visual understanding.
Okay.
It all starts with the way the model sees an image. Instead of processing the whole picture at once, it breaks it down into smaller visual chunks
Okay.
called patches.
Interesting. So it's kind of like putting together a puzzle where each piece is a patch of the image.
That's a great way to think about it.
Okay, cool.
But these patches aren't just random sections.
Right.
They represent meaningful visual features,
Oh,
like
wow.
edges, textures, or patterns.
So the model is looking for the building blocks of the image,
Yeah,
the elements that give it structure and meaning.
exactly.
Okay.
And here's where things get even more interesting. The model doesn't just analyze these visual patches in isolation. It also looks at the relationships between them.
So it's not just about what each piece looks like, but how they fit together to
Yeah.
form the bigger picture.
You got it. The model learns to recognize patterns and connections between these patches,
Okay.
which helps it understand the overall composition and layout of the image.
Okay, so the model is building this rich understanding of the image by analyzing both the individual parts and how they relate to each other.
Right.
But how does it connect that visual understanding to the explanatory instructions, which are in the form of language?
That's where the magic of the vision language model comes in.
Okay.
This model has been trained on a massive data set of images and text.
Right.
So it's learned to associate specific words and phrases with corresponding visual features.
So it's like a bilingual dictionary. But instead of translating between two languages, it's translated between the language of images and the language of words.
That's a great analogy. So when the model receives an explanatory instruction, it first breaks down the instruction into individual words and phrases.
Okay.
Then, using its internal dictionary, it maps those words to their corresponding visual representations.
So if the instruction says something like, add a soft glow to the edges of the object, the model is able to identify the visual features associated with soft glow and edges.
Precisely. And then using its understanding of the image's structure
Yeah.
and the relationships between the patches,
Yeah.
it figures out how to apply those visual transformations to achieve the desired outcome.
It's like having an AI art director that can understand your creative vision and execute it with precision. That's so powerful.
It is. And this ability to connect language and visual understanding is what enables the model to achieve that impressive zero-shot generalization we talked about earlier.
Right, because if the model understands the concepts behind the words, it can apply them to situations it's never encountered before,
Right.
even if the specific wording is new.
Exactly. And this opens up all sorts of possibilities for how we can interact with AI in the future.
Absolutely. But I think it's important to acknowledge that this research is still in its early stages.
Yeah.
What are some of the limitations or challenges that the researchers identified?
Well, one of the key limitations is that task-level zero-shot learning, while promising, is still primarily observed in tasks that involve less abstract or high-level visual transformations.
So while the model might excel at generating images from simple sketches or enhancing photos based on detailed instructions,
Right.
it might struggle with more complex creative tasks
Yeah.
that require a deeper understanding of abstract concepts.
Exactly. The researchers theorize that this limitation might stem from the initial pre-training of the model.
Oh,
The datasets used for pre-training might not contain enough examples of diverse and abstract visual styles, which could limit the model's ability to grasp those concepts fully.
It's like if you only ever read one genre of books, you might have a harder time understanding and appreciating different literary styles.
Yeah.
the model needs a broader exposure to different types of visual literature to expand its creative vocabulary.
That's a great analogy. And it highlights an important point about AI development in general.
What's that?
The data we use to train these models has a significant impact on their capabilities and limitations.
So it's not just about building more powerful algorithms. It's about carefully curating the data that shapes those algorithms.
That's right.
That makes a lot of sense.
It does. And it's something that researchers are acutely aware of as they continue to push the boundaries of AI.
Well, I, for one, am incredibly excited to see where this research leads.
Me too.
Before we wrap up, I'm curious to hear your thoughts on the bigger picture implications of explanatory instructions.
Sure.
What does this research tell us about the future of AI and its potential impact on our lives?
Well, it's an exciting glimpse into a future where we can communicate with AI in much more intuitive and natural ways.
Yeah.
Imagine a world where we can simply describe what we want, and AI can understand our intentions and translate them into action.
Right.
Whether it's generating images, designing products, or even creating entire virtual worlds.
It sounds almost like science fiction, but it's becoming increasingly real thanks to research like this.
Exactly. And as this technology matures, it has the potential to revolutionize countless fields from art and design to education and scientific research.
Okay, before we get too far into the future, let's bring it back to the present.
Okay.
I'm sure our listeners are curious to hear about some more concrete examples of what this model can actually do.
Of course.
Can you walk us through a few of the most impressive results from the research?
Absolutely. One of the most captivating examples involved a landscape image. The instruction given to the model was enhance the segmented scene by introducing detailed textures and colors, replace the dark green sky with a natural, clear blue sky, transform the medium blue ocean into a deep blue hue with a calm surface.
Wow, that's incredibly detailed. So it's not just about identifying objects or making simple adjustments.
Right.
It's about understanding and applying nuanced concepts like texture color and even the mood of the scene.
Precisely. And what's remarkable is that the model was able to successfully execute this complex instruction, demonstrating a level of visual understanding that goes beyond simple pattern recognition.
Did the researchers test the model on other types of images as well?
Yes, they did. Another compelling example involved a portrait photo. The instruction was to orient the head to a frontal perspective while ensuring the subject's gaze remains consistent, adjusting the balance of features to maintain a natural appearance.
So it's not just about manipulating the image at a pixel level, it's about understanding the underlying structure and proportions of the subject and making adjustments that preserve its realism.
Exactly. The model had to understand the anatomy of the human face, the direction of the gaze, and how to adjust features like the eyes, nose, and mouth to create a believable transformation.
These examples are truly mind-blowing. It really highlights the potential of explanatory instructions to bridge the gap between human intention and AI execution in the visual realm.
I agree. And what's exciting is that this is just the beginning. As researchers continue to refine these techniques and train models on even larger and more diverse data sets, we can expect even more impressive results in the years to come.
I can't wait to see what the future holds. But for now, let's take a step back and consider the potential downsides.
Sure.
With any powerful technology, there are always ethical considerations to address.
That's an important point. While this research focuses on the technical capabilities of AI, it's crucial to think about the potential societal impact as well.
Right. For example, I imagine there could be concerns about the potential misuse of this technology.
Yeah.
Particularly if it falls into the wrong hands.
It's certainly something to be mindful of. As with any powerful tool, there's always the risk of it being used for harmful purposes.
Right.
It's essential to have open and honest conversations about the potential risks and benefits of this technology as it continues to develop.
I completely agree. We need to ensure that AI is used responsibly and ethically for the benefit of all. But for now, let's focus on the positive potential.
Okay.
This research is incredibly promising, and I'm excited to see what the future holds for explanatory instructions.
Me too. And I think the most exciting aspect is the possibility of a future where AI can truly understand our creative intentions and collaborate with us to bring our visions to life.
That's a future I'm definitely looking forward to. And on that note, I think it's time for us to wrap up this segment. Listeners, stay tuned for our final thoughts on explanatory instructions and what they mean for the future of AI. Okay, so we've been talking a lot about this research and all the technical details, but I think it's important to kind of step back and think about what this all means, like for you, the listener.
I agree. This research, it might seem pretty technical at first glance,
Yeah.
but it has some really profound implications for how we approach creativity and problem solving in this increasingly AI-driven world.
Absolutely. It's not just about, fancy algorithms.
Right.
It's about changing the way we communicate with machines. Like, fundamentally.
Exactly.
Imagine a world where you could just ditch all the complicated software interfaces and just tell your computer what you want it to do.
Like you're talking to a person.
Yeah, exactly. It's like bridging that gap between human intention and like AI execution.
Instead of being limited by menus and buttons, you could just articulate your vision and watch as AI helps you bring it to life.
It's funny. It's like that scene in Star Trek.
Oh, yeah.
Where they just talk to the computer and it understands.
Computer make it so.
Exactly. But instead of spaceships, we're talking about everyday tasks, creative endeavors, you name it.
Think about the impact this could have on fields like graphic design or photography.
Yeah.
Imagine being able to describe exactly the look and feel you want in an image, and then have AI generate it for you.
It would be a game changer. No more fiddling with sliders and settings.
Exactly.
Just pure creative expression.
And it's not just about making things easier.
Right.
It's about pushing the boundaries of what's possible.
Yeah. What if we could use explanatory instructions to design like virtual worlds?
Oh, wow.
Craft these immersive experiences just by describing them.
Yeah, just by saying what you want.
Exactly. Like imagine the potential for education.
Oh, huge.
Students could describe historical events, scientific phenomena, and then experience them firsthand in a virtual environment tailored to their learning style.
Or architects using this technology to design buildings.
Yeah.
Not by drawing blueprints.
But by describing the emotions and experiences they want to evoke in the people who will inhabit those spaces.
That's incredible.
That's amazing. But with all this amazing potential, we do need to talk about the potential risks as well.
Of course, with any powerful technology comes the potential for misuse.
Exactly. We need to make sure that these technologies are developed and deployed ethically.
Absolutely.
With safeguards in place to prevent harm and ensure fairness.
It's a conversation that has to happen alongside these technological advancements.
Yeah, we need to be asking tough questions like, who has access to this technology?
Right.
How do we prevent it from being used to manipulate or deceive?
Yes, and how do we ensure that the benefits are distributed equitably?
Exactly. These are all really important things to consider.
They are, and there are no easy answers.
Right.
But it's essential that we have these conversations now while this technology is still being developed, so we can shape a future where AI is used responsibly for the benefit of all.
So this research into explanatory instructions, it's more than just a cool technical feat.
It really is.
It's a reminder that the future of AI is not predetermined.
Right.
It's something that we're all actively shaping through the choices we make and the questions we ask.
What kind of future do we want to create with these powerful new tools?
Exactly. That's the question we all need to be thinking about as we move forward into this exciting new era of AI.
I couldn't agree more.
And as always, we want to hear your thoughts. Share your aha moments, your concerns, your wildest AI-powered dreams with us on social media or through our website.
Let's keep this conversation going.
Yes. This is just the beginning of a fascinating journey, and we're so glad to have you along for the ride. Thanks for tuning in, everyone, and we'll see you in our next deep dive.
Bye, everybody.